In this video we'll discuss why the division algorithm works. Now if we have to do long division, we use what I call a house. Inside will go the dividend, the divisor goes on the outside, and your quotient will end up on top of the house. We start and we look at single digits to start the problem. Looking at the leftmost digit, we see how many times does the divisor go into that single digit. We write that above the digit, and then we multiply it by the divisor and subtract it from that digit in the dividend. We then bring down the next number in our dividend and repeat the process over and over again until we get through the ones place, and then we either have a remainder or we end on 0. If we do have a remainder, we want to put that remainder over the divisor. So if I had 345 divided by 21, create my house, 345 on the inside, 21 on the outside. I then start with the very first digit and say, how many times does 21 go into 3? 0 times. 0 times 21 is 0, so I have 3 left over. I bring down the next number, which is the 4. How many times does 21 go into 34? 1 time. 21 times 1 is 21. Subtract and I get a remainder of 13. I bring down the 5. Now I'm looking at 135. 21 will go into 135 6 times. 21 times 6 is 126, leaving me with a remainder of 9. So I have the quotient is 16 remainder 9, which we will write as a mixed number as 16 and 9/21 or 16 and 3/7 as a simplified fraction. Now if I didn't know long division, I could still solve the problem by just taking out amounts that I do know will go into the dividend. So, say I have that same problem. I am not sure how to use long division, but I do know some multiples of, I can do multiplying 21 times, say, 10. And I know 21 times 10 is 210. That's less than 345, so I could just subtract that out of 345. That would leave me with still 135 left over. Maybe I'm still not sure what to do, so I use, say, 4. 21 times 4 is 84. I can pull 84 out of 135. That leaves me with 51. Well, now I'm getting to a little bit smaller, easier numbers to work with. I know that all that's left is I could go 2 more times. And I pull 42 out of 51. That leaves me with 9. I can't go any further, so I know that's my remainder. So it's going to be 9/21. If I add those 3 red numbers, 10, 4, and 2, I'd end up with 16 in the 9/21 or 3/7. Now there's another method that's very similar called the scaffold method, except it makes us think about place value. We're always thinking about how many hundreds, how many tens, and then how many ones can I pull out. In essence, 100 times 11, 200 times 11, 300 times 11, 400, and then 10 times 11, 20 times 11, 30 times 11. So looking at each of those place values to pull out the numbers. So if I look at 200,456 divided by 11, and do it place value based, the scaffolding method, I'd be looking at the hundreds. Can I do 100 times 11? Yes. Can I do 200 times 11? Yes. Can I do 300 times 11? No, because then I'd be at 3,300. So 200 times 11 is 2,200. This leaves me with 256. Now I'm going to go through my tens. Can I do 10 times 11? Yes. Can I do 20 times 11? Yes. Can I do 30 times 11? No, because then I'm at 330, too high. So I'm going to pull 20 out. 256 minus 220 leaves me at 36. Now, can I do 1 times 11? Yes. 2 times 11? Yes. 3 times 11? Yes. 4 times 11? No. So I have to stop at 3. 3 times 11 is 33. This leaves me with a remainder of 3 in this problem. So I would know that my solution would be the 200 plus the 20 plus the 3 in my remainder of 3/11, so 223 and 3/11. Now why does this work? Think about what I was just saying. First thing I would say is, can I do 100 times 11? Yes, it gives me 1100, so I subtract that out. Can I do 100 times 11 again? Yes. Subtract another 1100 out, gives me 256. I can't do 100 times 11 again because it's too big. So now I'm going to go to my tens. 11 times 10 is 110. I can pull 110 out. I can do that again. Pull out 110. Now I'm left with 36. Well, I can't pull out any more 10s, so now I'm going to start pulling out 1s. 11 times 1 gives me to 25. Another 11 times 1 gets me to 14. Another 11 times 1 gets me down to 3, my remainder. And if I think about what I have here, I have 11 times 223, because I can add up all my red pieces, plus my remainder of 3 should equal 2,456. And if I'd seen that in the long division, I would have had 223 with a remainder of 3 in my quotient. So all we're doing with scaffolding and the long division is shrinking this long process into a single problem.